Next I need to find out the sliding velocity at the instant of engagement commences, as well as sliding velocity at the instant of engagement terminates. Okay, for that so you are having formula VSA, I'll take it. Okay, so velocity at the engagement begins. Okay, for that I'll take it as sliding velocity J. Okay, that is omega 1 plus omega 2 into LPOA. Okay, that is approach, length of path of approach. If you multiply this summation of angular velocity of gear and angular velocity of pinion with LPOA, that is length of path of approach, you will get this sliding velocity at the instant of engagement commences. Okay, similarly I'll let it as VST, terminates. Okay, T means terminates and A means approaches. Okay, at the instant of engagement commences, this is terminates. Okay, for that same formula, omega 1 plus omega 2, this summation is multiplied by LPOR, length of path of recess. Okay, so if you find these values, you'll get these two. Fine, it's very simple. So first we'll go for VSA, V suffix SA, that is equal to omega 1 plus omega 2 into LPOA. For omega 1, you know that the formula is V1 by R. Okay, that is linear velocity or rolling velocity divided by capital R. Omega 1 is corresponds to larger wheel. Okay, this is the angular velocity of larger wheel, that is why I am taking capital R. Okay, so V1 is equal to V2, so that is pitch line velocity. Okay, pitch line velocity 1.2 meter per second, that is nothing but your rolling velocity or pitch line velocity. Okay, or linear velocity. Okay, so you are having V1 value 1.2 meter per second, and radius, so it is in meter, I need to convert it into millimeter, 1200. If you multiply with 1000, okay, to convert millimeter, 1.2 into 1000, so that you will get 1200 divided by capital R is 152.75, so that you will get omega 1 7.855 radian per second. This is the angular velocity of larger wheel. So next I need to find out omega 2, right? This is the angular velocity of smaller wheel or pinion. So instead of capital R, you substitute small r, and instead of V1 it is V2, as V1 is equal to V2, you will get 1200 divided by 61.75, so you will get 19.433 radians per second. So this is the angular velocity of pinion. So you are having both omega 1 and omega 2, you need to find out LPOA and LPOR. So you already know how to find out the values. LPOA is equal to, you are having formula square root of capital RA square minus R square cos square phi minus R sin phi. You are having all the values, please substitute, so that you will get 16.8157 millimeter is length of path of approach. Similarly, LPOR is equal to square root of small RA square minus R square cos square phi minus small r sin phi. You're having all the values, substitute, you'll get 14.81 millimeter. So you substitute these values, equation number 1 and equation number 2. VSA is equal to you will get I'll substitute, then simplify. Omega 1 is 7.855 plus 19.433 into LPOA is 16.81. okay, 16.8157. so you will get 458.934 millimeter per second. So all the values in millimeter, so I'll get millimeter per second. Similarly, VST will get same values, but instead of approach you substitute races. So 7.855 plus 19.433 into 14.81, you'll get 404. Sorry, after substituting 404.20 millimeter per second. Okay, so this carries 16 or 20 marks in your examination. Okay, it is very important. Thank you.